Hello students, coming up with the lecture 2 on the topic statistics. Since yesterday we learned about how to find mean using direct method. This was also learned by you in class 9th. Here I have told you the other two methods that we will be using in class 10th. One being the assumed mean method, the other being the step deviation method. I have also told you the formula for the same. As I told you yesterday, these two methods are not different than the direct method. Direct method was not different than the normal method, sum of all observations upon number of observations. In this way, these two methods are also the same as direct method. Learning the formula, I'll tell you how to learn. It's very easy, and these two methods are just for making your calculation easier. So don't take it as a panic that how you will understand. Before moving further on these topics, let me at first tell you for what type of data can we use which method. So this first method, sum of observations upon number of observations, this can be used for individual series. This direct method, this we can use for discrete data, or when we have frequency distribution table. As I mentioned yesterday, this is for tabular form of data. So these two are the tabular form. Next is assumed mean method, and the fourth one, the step deviation method. These two both can be used only for frequency distribution table. Rather, these can be used for discrete data also, but it is convenient to use them for frequency distribution table only. So now coming to the next method, that is assumed mean method. So here it comes, assumed mean method. Since the name itself says assumed mean, so here we have to assume mean at first. Now how we will assume the mean? For that we have to understand, as we learned in our previous lecture, the first method, when we find mean, so we have 2, 2, 3, 4, 4, 4, 6, 6, 8, 9, 11. These are the observations. When we converted it to the table, it gives 2 with frequency 2. That means here we must understand that the frequency is not something where we get mean. We get mean from the observation. This information will be useful for avoiding one of the major mistakes that we do in this method. So at first, let's take one data. So initially we are taking a small data with 5 class intervals only. Let's revise the knowledge about the frequency distribution table in this way. This 0 to 10 is a class interval in which this 0 is the lower class limit, 10 is the upper class limit. There are 5 class intervals, and if we talk about the class size, that means we have to subtract the lower class limit from the upper class limit. Then we get the class size. So 10 minus 0 is 10. So class size for this is 10. So finding it with assumed mean method, we have a data, class interval and frequency is given. So at first, as we learned in the previous class, when class interval is given, we have to find the mid value of the class interval, and which we mark as xi. So let's at first find xi. The mid value of 0 and 10 is 5, 10 and 20 is 15, 20 and 30 is 25, 30 and 40 is 35, and 40 and 50 is 45. Here we find the mid values. Again, we know that these mid values are taken from the data that we had, not from the frequency. Now coming to this method, as it is assumed mean method, so we have to assume one of the observation as mean, and which that observation should not be from the frequency. As we know, the mean can be taken out from this observations. So this is why I have told you that these are of no meaning if we write this data in the form of individual series. So with this point you will be able to learn that this assumed mean A has to be taken from this data mid value, not from the frequency. I hope you can now understand. Now, who can decide that which value can be taken as the assumed mean? Is there any perfect criteria? Actually, no. Any of the value can be taken, but for the sake of the convenience, for making the calculations easier, we must take this middle value as A, which is our assumed mean. Now we have to learn that the next method for finding next step for finding assumed mean method mean is finding di. Why? Because in the formula we had fi di, so we will find di. And what is di? We have learned here it is xi minus a. So here we write di is equal to xi minus a. Our a is 25 as we have written. So 5 minus 25 gives minus 20. 15 minus 25 gives minus 10. 25 minus 25 gives 0. 35 minus 25 gives 10. 45 minus 25 gives 20. So here we have found di very easily. Now the next step, as we can easily understand, is finding fi di, because in the formula we have to find sigma fi di. So fi di we can easily calculate. 2 multiplied by minus 20 gives minus 40. 4 multiplied by minus 10 gives again minus 40. 3 multiplied by 0 gives 0. 6 multiplied by 10 gives 60. And 5 multiplied by 20 gives 100. If we add them all, we have to take the negative terms along, that is minus 80, and positive terms along, that is 160. So the total becomes 80. 160 minus 80 gives 80. Now coming to find the mean, formula is mean is equals to A plus sigma fi di upon sigma fi. So A we have taken assumed mean as 25. So A is 25 plus sigma fi di. Let's see this sigma fi di. It is 80 upon the sigma fi, which is sum of all the frequencies. Let's count it. 2 plus 4 6, 6 plus 3 9, 9 plus 6 15, 15 plus 5 20. So the calculation becomes here very easy. 80 upon 20, which is 25 plus 4. 80 upon 20 is 4. Hence our mean becomes 25 plus 4, that is 29. So was this method difficult? I think no. In fact, it made our calculations easier. Otherwise we would have been involved with 2 5s are 10, 60, 75, adding them and having a large number as the addition of all. The division would have been quite difficult. But here we have got this mean very easily. Now comes the point how to learn this formula. So the learning is very easy. Since you know in assumed mean method we are assuming one of the mean, that is A, and we are subtracting. So when we are subtracting A from xi, we are getting di. Therefore when we have di here, so we are adding A. Suppose, let's understand with this an example. Suppose you have a packet of chocolates which you have to give to someone, but since you are fond of chocolates, you ate one of them. But when you have to give that chocolate to that someone, again you have to put in the chocolate back. So this is, since we have subtracted A from this to make our calculations easier, like to feed our belly with the chocolate. So while coming to the final calculation, while returning the packet, we have to add back that one chocolate. That means this A. I hope this makes your understanding easier. Now the next video will be on step deviation method that we have kept here, and this is again very easy and derived from these methods only. Happy learning. See you tomorrow.